Alright, hey everyone, this is Wes, and today I'm just going to make a quick little video on showing you how to create a C project in Atmel Studio. So just like with assembler projects, we're going to click New Project, and the first difference is instead of assembler, we're going to choose C/C++, and then make sure you choose C executable project. It's possible to write code in C++ for the Xmega, but for this class we require you to use C. And then I'm going to name the project something, so I'm just going to pretend I'm working on lab 5, and then I'm going to save it into a 3744 labs directory. And then make sure this checkbox is ticked, so it'll create a folder for you with the project name as the name of the folder, within the whatever directory you specify. Click OK, and then I usually type in 128A1U, the kind of the suffix of the device, because I know it's unique, and then make sure it's ATX Mega 128A1U and click OK. So this is going to create a blank C project with a main.c file, and the main.c file has the main function. And this is where the majority of the code for the application of your lab will go. So I'm going to start off by renaming it to something that's relevant for the lab. So the naming convention we're using currently is the lab number underscore the part number. So I'll just assume I'm working on section 1. Okay. So now you can write any code you need to here. So initializations and things that only you want have to happen once will go typically above the while loop, and then any code that you may want to happen repetitively will go in the while loop. So in C, a while loop runs some chunk of code as long as the argument or the value within the parentheses is true. And in C, any value that's not 0, whether it's 1, 2, 3, whatever, or a variable that is not 0, is considered true. And 0 is considered false. So a while one loop is a while loop that just does something forever, or as long as the program's executing. Okay, so just like with assembly projects, you had either a while loop at the end of your code, so that it didn't run into nowhere in program memory, or you had some loop or block of code that happened repetitively. So depending on what type of application you have, you'll have to organize this differently. And then the next thing is up here we have #include, which is similar to the .include assembler directive, except this is the syntax for C. And then you can include the io.h file, which includes the actual include file of the device, just like in assembly. I'm also going to update this since I changed it over here, just to be correct. And you'll need to replace this with the template that we tell you to do when you submit your labs. Okay, so the next thing I'm going to do is show you how to add more files to the project. So if you start working on, say, the next part of the lab, and you don't want to have to create an entire new project just for each section, what you can do is right click on the project name here in the Solution Explorer, click on Add, and then you have two main options. You can add a new item or an existing item. The existing item is if you have another C file, say from another lab, that you've already written, but you don't want to have to write it again, you can include that, which basically either copies it into your solution directory, or you can make it link it so that it doesn't physically copy it. It just has the link from wherever the file is located on your computer. And then you also have new item, which will create a new blank file that you can write code from scratch with. That's the one I'm going to choose for this. And then I'm going to add another .c file because it's going to be for another part of the lab. So I'll continue on with the naming convention here and do lab5_2.c. Click Add. And then what I typically would do is, if the two sections are related, you can just copy the code from the previous section of the lab, paste it into the new one, and then you can kind of make your modifications and additions from there. So the first problem we'll run into with this is the main function will be defined twice. So if I click build here, I'm going to get an error, multiple definition of main, because in C you're not allowed to have multiple functions with the same name. So what I'm going to do is, instead of moving this to another project or something like that, I'm going to click on the one that I no longer want to build. I can right click on it and click properties. That's going to open this properties window here. And if I change build action from compile to none for the ones that I don't want to compile currently, then if I build again, I'm going to get build succeeded because it only built lab5_2. Okay, and then I can do this repetitively for the next part of the lab. So I'll do one more as an example. lab5_3.c. Copy the code from the previous part. Oops, didn't mean to do that. Okay, and then after I do that, I'm going to change this from compile to none. Click build, no errors, and it's only building this section. And then if I want to go back to say demo another section in lab, I can change this one to none, and then if I wanted to show section 2, I can change this back to compile. And any files that don't have this this red warning sign here means that they're going to be compiled. Okay, so if I click build one last time, get build succeeded, I'm good to go. Okay, so those are the basics of creating a C project. There's more advanced things you can do, like creating supplementary driver files, like a pair of source and header files and stuff like that. But this video is just going to be simply creating a project and adding new files for each section. Alright, hope this helped. See ya.